z-axis will generate the crystal. So our purpose is only confined because we cannot go to the whole crystal. It contains thousands and thousands of unit cells. I am talking of simple organic compound. If I talk of proteins, viruses, if I crystallize some protein or virus, so then thousands of atoms are there. Then it is not possible. So you're just like it. Once you know the composition of a brick, you can say what is your wall made of. So whatever is there in a brick, your wall is also of the same structure. So similarly like this. What is shape of the unit cell? So your whole system can be constructed by repeating it along x-axis, by repeating it along y-axis, by repeating it along z-axis. So in some cases with simple crystal structure, the planes also correspond to layers of atoms, but this is not generally possible. So some of the assumptions upon which Bragg lies based may seem to be rather dubious. For instance, it is known that diffraction occurs as a result of interaction between X-rays and X, which Bragg does not say. He only talks of planes. Whether in a plane there is atom or not. If there the output scatter radius. So this is not the case in case of Bragg. Further, the atoms do not reflect X-rays but get diffraction. So there is a difference between reflection and scattering. Scattering is the phenomenon suppose there are 1000 atoms in a crystal. So all atoms they will scatter X-rays. Now in some directions X-rays they constructively interfere, in some directions they destructively interfere. So net result what we get from a crystal is diffraction. So this is a basic difference between scattering and diffraction, which students fail to reply when we ask. You take single atom, you take a ray, then you put some atom and then you make all radiations in all directions, 360 degree, all directions, X-rays are emitted from atom. Then you take another atom, it will also emit scattering, it will do scattering and emit rays in all the directions. So when these rays combine, then you get output of few, hardly 1 or 2% of the incident intensity, a diffraction pattern, few radiations. So this is a basic difference between scattering and diffraction. Diffraction is a macroscopic phenomenon, you can say. Scattering is a microscopic phenomenon. Combination of large number of scattering events gives us phenomenon, we call it as diffraction. So we say X-rays are scattered by constituent particles of a crystal. Or we say X-rays are diffracted by a crystal because wavelength of X-rays is very, very small comparison to the crystal. Crystal, when we talk of the size of say sugar piece, so it is a crystal. So X-rays that gets reflected by the sugar piece, gets scattered by the constituent which are making the sugar piece. This is a basic simple example you give to the student. So difference between scattering and diffraction. Normally in books it is written diffraction wavelength must be of the comparable size to that of the dimension. It's okay from the broader point of view. But when we have to differentiate between scattering and diffraction, then definition is in scattering dimensions of the obstacle and wavelength of the wave they are comparable. But in diffraction dimensions of the obstacle are much larger than the wavelength of the wave. I am talking of in comparison, but normally we say diffraction tabhi hogi jab comparable honge. It's okay if you don't bring scattering into picture. Once you bring scattering into picture, then that definition is gone. We therefore happily use terms such as reflections, often deliberately with this alternative, but incorrect spelling. And bear in mind that we are fortunate to have such a simple and picturesque, albeit inaccurate way to describe what is reality in a very complicated process. So diffraction is very, very complicated process because you are extracting information at the atomic level. How atoms are sitting in the crystal, what are the interactions involved, how hydrogen bonding taking place, from simple output of intensity of rays. You don't have in your hand nothing. Simple, you have in your hand at what angle, at not angle, you cannot find the angle, from which plane, what scattering you are getting. So your output is HKL and I. From HKL and I, you have to construct your inner of a crystal and the interactions which are responsible to make it as a crystal. So it is not as simple, whatever no machines have made it, this subject. Earlier, 40, 50 years, it is the most complicated subject. That's why a lot of mathematicians, chemists, physicists, biologists, they were doing all this kind of stuff. Because unless you have structure in your hand, you cannot do any kind of medicinal activity. So that all depends upon the kind of interaction present in a molecule. From there, you can see receptor attack, receptor binding. So all these studies, medical point of view, you must have structure in your hand. That's why the position of atom in a molecule are important. How atoms are sitting and how they will act at a particular site in the body. So that's why for medicinal point of view, you must have structure in your hand. Otherwise, it is very, very difficult to find out any exact treatment of any thing using medicine. So for medicine point of view, crystal structure of that particular medicine, that is the first hand information you should have in your. How is it that we are able to get information about lattice parameters of the order of atoms, atoms which are so closely spaced using H-bar? So now we will come to that. कैसे हम ये information, how we can extract information from the data which is of very, very limited. Because you cannot get anything. Suppose you must have in your lab, some of you, simple lava experiment or rotation experiment. What you are getting? You are putting a crystal, then you are shining X-rays. In the output, you are getting black spots. Or if you have some counter, on the computer, you are showing to the student 1000 intensity of this reflection, 100 intensity of this reflection. So then you find out by indexing lava photograph 100 plane this. If you have to visually find the intensity, then you take some comparative scale and you say this intensity, so relative intensity you can find out. So similarly, in all diffraction experiment, whatever lava giving, that is also diffraction which is also doing in electronic way. It is giving you HKL and intensity. So now we will see how we can extract information from this limited output we have in the hand. So diffraction is a process in which linear information means d spacing of the plane, is converted into angular spacing, the angle of diffraction. So then we have to find out at what angle this reflection is coming. So we have to convert d into theta. This also implies that in XRD we are concerned with angular resolution instead of linear resolution. The missing reflection, which is very, very important, because whenever start your work, once you have it in your hand, you have then decided my crystal system is monoclinic. Knowing monoclinic, out of the 14 various lattices, then you have to find out one lattice. Then your basic aim is, we have 14 gravities lattices, 32.5% to 30 spaces. And your crystal belongs to one gravis lattice, one point group, one space. So first hand information you have to extract 1 out of the 14, 1 out of the 32, 1 out of the 230. This lecture I will take. Why do we have 14 gravis lattices? Why do we have 32 point groups? Why do we have 230 space groups? So here also we have to find space group is your based on unless your space group is correct, is not correct, you are unable to solve the structure. For solving any crystal structure, your space group must be correct. So the basic expertise which is required. You have to decide which space group you have to give to the input. Whether it is P21, P1YA, P21YN, hardly very small difference is there. All expertise lies in correctly identifying what is the phase group. We have mentioned that Brag's equation is a negative statement. Why negative statement? That is just because Brag's equation is satisfied, a reflection may not be observed. Brag's equation gets satisfied depending on the interplanar spacing, not on the basis of whether in that plane you have the scatterer means atoms are present or no. Let us consider the case of CUK alpha radiation. Yesterday we have seen 1.54 being diffracted from 100 planes of molybdenum. Now we are taking a molybdenum crystal and prediction on a molybdenum crystal. So we have to find out the structure of molybdenum. As you know, molybdenum is a body-centered cubic lattice. If it is a cubic lattice, it has only one cell parameter, that is 3.51. This is your 100. Now you can see, if I take simple cubic lattice, then atoms at the corner. What molybdenum is a body-centered cubic lattice. So here one atom in the center of the unit cell. Now X-rays are coming, they are reflected. So from here also, now it will, if it is, then it's okay. Green lines, they are in phase. I will get constructive interference. No issue. Now once your unit cell is body centered, one atom is at the center of the body, here also X-rays gets reflected. Now contribution of atoms at the corners is 1. Because it is contributing 1 by 8, 1 by 8, 8 unit cells are attached here. So total contribution of these corner atoms 1, 2, 3, 4, 5, 6, 7, 8 is 1. And the contribution of this atom to the body, it is not joining to any other, it is not sharing to anyone. Its contribution is also 1. So it will also then, what these 8 atoms will scatter, same single atom will scatter. Though it is scattering, it is out of the phase. It will cancel this, we will get nothing. That's where it comes that distance. I am again and again from the beginning telling why some reflections are missing. Here I will get nothing because output will be 0. Based on this, from which plane it is coming, even HKL, so which HKL is giving me missing reflection. This we call it as HKL. How it happens, you have seen yourself. If it is not body-centered cubic lattice, then I will get only constructive interference, no extinction. But if the atom is here, it is now giving me the wave which is destructively interfering the above and below wave. And its contribution is 1. Corner contribution is 1. Let us consider the case of copper K radiation. So here lambda is equal to 100 plane I am talking of. Now this is your 200 plane because in the middle there is one plane. But this reflection is absent in this. We don't get this intensity at this angle. The missing reflection is due to the presence of additional atoms in the unit cell, which are positions at lattice points, which we shall consider next. The wave scatters from the middle plane, this plane, this colored one, is out of phase with the one scattered from top and bottom. You can see, here scattering wave is this, here scattering wave is this, but it is opposite. That is, if the green rays are in phase, so kitna part difference is lambda, then the red ray will be exactly out of phase with the green ray. Part difference is lambda bar. However, the second order reflection from one is planes which is equivalent to the first order reflection from 2 plane is observed. So this is because the green rays have a path that can only happen if here it is part difference of 2 wavelengths. Only then one wave will come in the middle. If have a path difference of 2 lambda, then the red ray will have a path difference of lambda. अगर वो lambda ही हुआ दोनों green में तो lambda by 2 हो जाएगा. Then तो possible नहीं हुआ, which will still lead to the constructive interference. Extinction नहीं होना कैसे possible होगा? अगर ये दोनों waves के बीच हुआ तब उसमें एक wave का difference आएगा. ऐसे ये half का आएगा, half इधर, half इधर. So why does the 100 reflection go missing? Why is it present? Come get missing here, come get present. Planes existed before and after introducing an atom in a unit cell center at this 1 1 by 2, 1 by 2, 1 by 2. 1 by 2, 1 by 2, 1 by 2 is to reach this atom, if this is my origin, I have to move half here, and then half in this direction, x, y, z direction. Thus, lattice centering does not lead to any base being scattered out of it. If there is a difference of two wavelengths and there is a set of atoms in the middle, in only that case we are not getting extinction, otherwise we are getting extinction. Now you take the case of one plane. Here now, same thing, atom is sitting in the middle. Now you can see this is one lattice. If I take one plane is like this, then all planes are present. Presence of additional atoms joins molecules in the unit cell, a lattice point, as we may choose a non-permittive unit cell. Permittive में तो होंगे, they always will be at the corner or as a part of the motif. Some of the reflection may even go missing. So position of the reflection please tell us about the lattice point. So once some reflections are missing, not always, but we get some idea that it may not be permittive lattice, it may be other than the permittive lattice. Maybe three-phase centered or body-centered. The intensities tell us about the motif, the kind of molecule present. So selection extinction rule. As we have noted before, even if Bragg's equation is satisfied, reflections may go with. What does it mean? Here Bragg's equation is getting satisfied because Bragg is taking this as one plane, this as one plane, he does not talk of atoms, this as one plane. For Bragg, nothing is absent, but when we talk of diffraction, reflection go on missing. The reflections present and the missing reflections due to additional atoms in the unit cell are listed in the table. If I take simple cubic lattice, in that case, all reflections are present. I am now talking of diffraction, not reflection. Although I have written reflection. Whenever we talk of crystallography, reflection means diffraction. Otherwise, reflection indicates in terms of Bragg. Because we don't have any additional set of atoms in the unit cell, so all reflections are present. If I take body-centered unit cell, H plus K plus L, they are present. If I take one reflection, 1 plus 1 plus 1, it will be 3. It is not even, so that reflection will be 3. So from there I can find out what is my space group. If I take 2, 1, 1, then that 2 plus 1, 3 plus 1, 4. That is even, that reflection is present. So कौन सी नहीं होगी? Necessarily absent 1 plus 1 plus 1. That is coming after, that is missing. If I take phase center cubic lattice, H, K and L unmixed, that is all even or all odd. 2, 0, 0, 4, 0, 0, 6, 0, 0, 0, 2, 0, 0, 4, 0, 0, 0, 2, 0, 0, 4, 0, 0, 6. They are present. 1, 0, 0, 0, 1, 0, 0, 0, 1. These reflections are off. And the center means three-phase center. Generally, it may be A or B. H, K and L unmixed. Maybe 2, 0, 0. Present, is not water. So, because for 230 phase group, we have once, I think in our lab we kept international tables of X-ray crystallography. It may be available online. So for all space groups, they have given this condition, HCl condition. For which space group, what should be the value of HCl? Based on that, we did the computer also, they have set this, all these conditions. So from computer we can find out our data belongs to which space group. So in the program also these information are there. This is how the things are finalized before something else. Now we will come to the Miller indices. I have yesterday also said this is very, very important topic from the point of view of graduation student. No student, hardly 1 or 2 students correctly plot the Miller indices. Otherwise all are just, I have to give 0 number. What are the Miller indices? Miller indices are reciprocal of the fractional intercept which the plane makes with the crystallographic axis. So from where the reciprocal concept came, it came from the Ivar's sphere. You must have studied the Ivar's sphere. In that case, what happens? We modify our Bragg's law. Bragg's law is 2d sine theta equal to n lambda. So in another way, we can write it 2d sine theta, then sine theta, we can write it 1 by lambda divided by 1 by d or n by d. Then we plot it in a right angle triangle in a circle. So after striking the crystal from where the reflection shoots out, that is at a distance, that becomes a right angle triangle. You just recollect the figure of Ival's here. So that is at a distance of 1 by dx, from where the reflection is touching the surface. So that's why we talk of reciprocal. So what reflections we are getting it in a reciprocal space. From there we convert it into the direct space. That itself requires one lecture reciprocal, that is. So that we start with the Ivar's sphere. Once you make the student understand what is Ivar's sphere, student will automatically make out why we are taking the reciprocal of the intercept. So whatever we are getting, you must have seen the formula of density period also. N lambda over 2d. So always interplanar spacing is in the denominator. In no formula it is in the numerator. Means 1 by d. So what we are getting is 1 by d, not d. So then we convert it into the direct line. So you see any formula of calculation of cell parameter. So always your d will be in the denominator. So Miller indices the reciprocal of the fractional intercepts which the planes make with the crystallographic axis. Your axial length intercepts lengths are a, this is along x-axis, this is along y-axis, this is perpendicular to the plane of the paper. So this is intercept is your AYH, BYK, CYL. Okay. Suppose I have to plot 4 to 1 plane. So my intercept will be, so your axial length is 4 Armstrong along x-axis. Your axial length B is 8 Armstrong along y or b axis and 3 Armstrong along z or c axis. Okay? We have divided into 8 parts, into 3 parts, into 4 parts. Now, you are given to plot 4 to 1 intercept. Similarly, so how you will find out the intercept? You take the reciprocal of this 1 by 4, 1 by 2 and 1 by 1. That is 1. So 1 by 4 intercept length is 1, 4 and 3. So 1 by 4 of this is here along x-axis. Because this you have to take as 1, means 1 Armstrong. So 4 Armstrong, your intercept will become 1 by 4. So y-axis, it will become 1 by 2. And C, it is parallel, you can say 1. So this is how, these are the very simplest, 4 to 1, 1 to 3, 1, 1, 1, 1 to 5. This every student will plot. What problem comes where? 2, 0, 0, 2 bar 0, 0. 3, 0, 0, negative intercept no student is able to, or when it is 0. 0 means if reciprocal, then it will become infinity, 1 by 0. Anything divided by 0 is infinity. Infinity means it is parallel. If z is infinity, it is not touching z. It is parallel to z axis. So similarly, if I take 0, 1, 0 plane, this means the intercept along x-axis divided by 0 infinity, it is not touching x-axis, it is not touching your z-axis, it is only touching your b-axis, 0, 1, 0. Reciprocal of intercept is 1 by 1, that is 1. 1 means full 8 strong. So I have to take it as 1. Whatever will be the value of the unit cell, maximum value is 1. It cannot be 1.1 or 1.2 or 2 or 3. Then we have to make it 1. The rest all will be intercept will be less than 1. maximum intercept is your 1. So in this case, you have to plot 0, 1, 0, only y-axis, it should not touch z-axis, it should not touch x-axis. If this is your region, then your 0, 1, 0 plane is this. Whatever red lines we have. Okay? Now we will come several atomic planes and their d-spacing in a simple cubic line. So I have said my intercepts are 1, 0, 0. In that case, here blue number in black numbers indicate fractional intercepts, blue numbers are the Miller indices. Then you have to find out the Miller indices 1y1, 1y0, 1y0. So that means 1, infinity, infinity. This means it is touching only your x-axis and parallel to y-axis and parallel to z-axis. So if this is your region here, this is your axis, you plot, here you put 1 point, you cannot put any point at v-axis, you cannot put any point at c-axis. So this is parallel to v-axis. And this colored one is your 1, 0, 0 plane. Then comes 1, 1 plane. What does it mean? Intercept will be 1y1. X-axis, your y-axis never touches that axis. Take this 1, 1, 1. You join all the three. This triangle we are getting, it is your 1, 1, 1 plane. Now we will come to 0, 1, 2. This is slightly complicated, but still it is okay. I have not taken yet the negative one, which is the most difficult, but once you have the understanding, most easy to plot. In this case, intercept is your infinity. It should not touch your x-axis, must be parallel to the x-axis. Y-axis 1, z-axis is 1 by 2. If this is your x-axis, this is your y-axis 1, z-axis of y2. So another unit cell will be here. You join their points also. So this plane is your 0, 1, 2. 1, 2 plane will always come in the middle because it is always reciprocal of the interplanar distance. So these are some of the Miller indices which students also know how to make. These are the simplest ones. Now we will come set of planes. So 1, 0, 0, if this is 1, 0, 0 plane, the unit cell which is on this side, for that this is 1, 0, 0 plane. So 1, 0, 0 planes are all this because we have thousands of unit cells along x-axis, thousands of unit cells along y-axis, thousands of unit cells along z-axis. So for this unit cell, 1, 0, 0 plane is this. For the unit cell which is following on this side, for that 1, 0, 0 plane is this. So now we will come to 2, 0, 0. Intercept will be 1, y2. So here it will come in the middle. So for this unit cell, 2, 0, 0 plane is this. The unit cell, here is also one unit cell only, then we can make a crystal. Because crystal is not a single unit cell. So for that, 2, 0, 0 plane will come here, somewhere here. Now we'll come to 1, 1, 1. 1, 1, 0. Here, this is your z-axis. Here it has not taken z, it has taken it as y-axis or this axis as 1. So here in the middle, so this axis is your z-axis he has taken, that's why it is not touching to this. It is parallel to this. Now 1, 1, 0. If I take this as the origin or this as the it has taken -110. No, 1 var 1 0. It's okay. 1 var 1 0. He has plotted. But for a student to understand what is the difference between 1 1 0 and 1 var 1 0 from this diagram, it is not possible. Because 1 1 0, it is also coming the same. 1 1 0, it is also coming the 1 var 1 0, it is also coming the same. It will come same, but then the main point is, if I am the examiner, I will give 0 number, because he has not written where is the origin. With what origin it is minus. So defining 0 0 0 is the most important thing. Here also I don't know what is the x-axis, what is the y-axis, what is the z-axis. So I have to write this is y, because if I take this x as x-axis, this as y, this as z, then this million this is wrong, because on z-axis we are touching it. So unless you write x, y, z, you cannot. Here it has written A, B, C. So if I take it as C, in that case, even then it is wrong. So for writing anything, you simply write x-axis, y-axis, z-axis, whatever. If you want it as axis, okay. You want this as y-axis, it depends on student to student. What student wants, what he thinks is simpler. No, 1 var 1 0 here and 1 0 0 here, they are the same. What? Nothing is defined here. Origin is not defined. Similarly, 1 1 1 var, here also nothing x, y, z, nothing origin. So it is not the correct way of making. Mostly students do like this. Sometimes we also see that it is correct. What correct on with respect to what? That is the main problem. 1 0 2. So then we will come to how to plot it. If you face any problem now, you just tell, we will discuss in between also. I have taken x, y, z. This is your x, this is your y, this is your z. In one unit cell, we will do all the million disease. We will not vary anything. So for making, for x-axis, if I take 1 0 0, means my intercept is 1 by 1 along x-axis, and it is parallel to infinity, infinity, means parallel to y and z-axis. Then this one, this plane is your 1 0 0. Simple way. If you are facing any problem, you just tell now. When you have to plot only 1 0 0, then you make it as colored, this plane. If it has come as 0 1 0, I have written here y-axis. In that case, my this red one, the upper face, not the downside face, upper face, red one, this is touching your y-axis and is not touching x and z-axis. This is your 0 1 0 plane. When I talk 0 0 1, means it has only to touch z-axis, not y and x-axis. This green one, 0 0 1. So if these three planes are, a student has to plot, make three unit cells like this, write x, y, z, and then the origin, which is the most important, origin. This is your 1 0 0, this upper face is your 0 1 0, and this top face is your 0 0 1 in the unit cell. Or you take a cube to the class and make the student understand on the basis of the cube. Now we will come to same with negative. 0 0 1 var, 1 var 0 0, 0 1 var 0. Now what I did, you can see, I have done nothing. I have only shifted the origin. For x-axis, my origin is this. I have made a unit cell. I have written x, y, z. I have not changed. I have, instead of writing 0 0 0 here, I have written 0 0 0 here. Now 1 var 0 0 means it is parallel to y and z axis and in the negative direction 1. So maximum value we have to take 1, because the rest all are, if I take 20, 20, 20, then my intercept is 1 by 20, 1 by 20, 1 by 20. So maximum value of intercept is 1. You cannot go beyond 1. It cannot be 1.1. So for 0, 0, 0, if I write here, minus 1 will be this one, minus axis. If I say, no, my x-axis are starting from here. This is my x-axis, this is my z-axis, this is my y-axis. So this is my minus x. So then this plane is your 1 var 0, 0. Make similarly. So instead of this face, now this face is your 1 var 0, 0. What? You have to write 0, 0, 0 here. If you say this is your 1, 0, 0 and write 0, 0, 0 here, then your Miller indices is. You shift the origin. Origin shifting is the most easiest way of plotting Miller indices and very, very easy for the students to understand. Now we will come to 0, 1, 0. What I did, I made now this diagram same ही रहेगा. It is the same diagram. Nothing I have changed. Now this is my y-axis, this is my origin, this is my x-axis, this is my z-axis. So minus 1 is, this is my minus y, then the downside face. Here it is the upper face, now this is the downside face of the unit. 0, 1, 6, red one. I don't see any problem to make student understand, or you take some cue, it must be available in everyone's house. So you say now this face is your 0, 1, 0. Now we'll come to 0, 0, 1, 1. For that, you have shifted your region here. Now here this is your plus z-axis, below is minus z-axis. This is your plus axis, this is your plus y-axis. So 0, 0, 1 are parallel to x and y, but minus z. So this green portion is your 0, 0. So for plotting negative of 0, 0, 1, 0, 1, 0, 1, 0, 0, I don't think there is any difficulty a student will face. Once you make him to understand shifting of region. For axis, we have shifted region here. For y-axis, we have shifted region here. For z-axis, we have shifted region here. Now, slightly complicated we will take. 1, 1, 0 and 1 var 1, 1, 0. Which we have studied here. 1, 1, 0 and 1 var 1, 0. I have taken here 1 var 1 var 0. 1, 1, 0 means it is touching your x-axis and y-axis but parallel to z-axis. So maximum value 1 of x-axis, maximum value of y 1 axis but not touching anywhere. If you take you keep one book in the diagonal way. That is your 1, 6, 1, 0 plane. In any cube you play diagonally any cardboard, that plane will reflect your 1, 1, 0 plane. Now, I have seen in the papers what students do for making negative, they will make one unit cell here, they will make one unit cell here. So that is not the correct way. So now for making 1 var 0, what I did, my intercept will be minus x minus y parallel to z-axis. I have made this as the origin now. It just you visualize the thing. What should be? You ask student, socho kya thing? What should be the origin? If I take this as the origin, then my minus x will be this, plus x is on this side, plus y axis is on this side, and plus z axis on this. Yet I am not to touch because it is parallel in any way. So then now instead of joining x and y, I have to join minus x and minus y. If I have taken this as original minus 1 minus x is here, 1 minus y is here. So now this is your plane. I have done nothing. Same diagram I have kept. 1, 1, 0 is also same diagram. 1 var 0 is also same diagram. What I did, if in the exam it is 1, 1, 0, I will write 0, 0, 0 here. If in the exam 1 var 0 is there, I will write origin. Diagram will remain same. You see, you don't find any difference. It is the correct way of plotting 1 var 0. Easiest way. Now we will come 1 var 0, 1 var. So for that I have made the same diagram. Kuch nahi change karna, nothing you have to change. No, it is up to you. It is no binding on you that this is always X, this is always Y, this is always X. You have made it. It is your choice. You have said that this is, I will say this is my X-axis, this is my Y-axis, this is my Z-axis. No one has forced you. No, I say no. I will write this as X-axis, this as Y-axis, this as Z-axis. How does it matter? It is only the understanding. I have made the student to understand. If I have written this as X-axis, this as Y, and this as Z, you have nothing to do this. In the same diagram, you make the student to understand. No, if it is instead of 110, 1